These notes are all about cast and impression evidence. You should be able to distinguish between patent, latent, and plastic impressions, describe how to make foot, shoe, and tire impressions, use track width and wheelbase information to identify vehicles, and prepare dental impressions and match them to bite marks. We'll be doing a lot of this in different labs. So people, vehicles, and objects leave evidence of their presence at accidents and crime scenes all the time. That often takes place in the form of impressions, where we have three different types of impressions. The first being patent impressions, which are two-dimensional, but are visible. Not to be confused with latent impressions, which are also two-dimensional, but are invisible to the naked eye. We're going to have to do something to make them visible. And then we have plastic impressions, which are three-dimensional, so they are made in some sort of soft surface, like a tire mark in mud. So let's talk about shoe impressions first. So the size of a shoe print can tell you the size of the foot of the person. If we have a shoe print left at a crime scene, we can measure it and figure out what size shoe that means that person wore and what their approximate foot size is going to be. The depth of a foot or shoe impression could tell us something about that person's weight. Heavier people are going to sink farther down than lighter people. The type of shoe could tell us something about that person's job or personality. Different people like different types of shoes or have to wear different types of shoes for their jobs, so that can help us narrow down things. Databases do contain the names of specific manufacturers and tread patterns used to identify different shoes. You can cross-reference a shoe pattern found at a crime scene with a database of existing known tread patterns, so that way you can say, we know that it's this type of shoe, and if you have a suspect, you could collect that kind of shoe if they had it. The thing about your shoes is when you wear them, you are actually personalizing them. So your body weight can personalize your shoes. Heavier people tend to wear down their shoes faster than lighter people. The way a person walks. I, for example, drag the very tippy back of my heel when I walk, so the very, very back of all of my shoes gets worn off. Maybe there's some people who kind of lean to the left or right when they walk, causing their shoes to wear out on that side. The surface on which a person usually walks. So I normally walk on the tile floor of this classroom. So that's causing my shoes to not wear down very much because the surface doesn't have a lot of friction. Meanwhile, someone works construction and they're always walking in dirt and gravel and all of that, their shoes are going to wear down a lot differently. Additionally, we can look at the debris that became embedded in the tread or unique holes and cuts in the tread that could help us tell where someone has been, going back to our soil evidence, but also if we can see that in the impression we know we have a strong match. So when it comes to the collection of shoe impression evidence, why would the following steps be important? So you want to take photos as soon as possible. The reason for this is impression evidence is very easily damaged or destroyed. So you want to get those photos so that you have evidence that that evidence was there in case it gets destroyed. You want to take multiple photos of the impression from at least two different orientations. So you're going to get your 90-degree angle shot like we've spent lots of time talking about as a requirement. But you're going to want to get it from also not a 90-degree angle because particularly with impression evidence, sometimes that can cause us to get details that are not visible from a 90-degree perspective. You want to place an identifying label and ruler in the position with the impression in the photo. This is important because this is solid forensic procedure and you want to be able to use your pictures in court. Use oblique lighting whenever possible. So oblique lighting is when you take light and instead of having it overhead like it is in my classroom, you move the light to the side. The reason this is important is because we can sometimes get details that were not visible when the light was overhead and allow us to get a better idea of how deep the tread patterns were and that kind of information. Now, some footprints at crime scenes are in mud or are just visible 3D prints, but a lot of times we get latent impressions of foot just like we did with our fingerprints. So there are different methods that we can use to make them visible. First one is luminol, which we first learned about in our blood unit, and it is often used because if blood was involved and even someone tried to clean up, we can a lot of times see evidence of those bloody footprints. We can also dust for latent prints, just like we did with fingerprinting. If you have reason to believe that there is going to be some oil or grime associated with that print, you could just dust to receive it. Now, a lot of times, though, these invisible ones, dusting is just going to destroy them, and if they aren't made in blood, luminol doesn't work. So two other processes are electrostatic lifting and gel lifting. Gel lifting is a process above, and these can capture hidden impressions. Gel lifting, you essentially take like this gel sheet and you press it down, and it's going to pick up everything that's there. Electrostatic lifting works a little differently, where you have this sheet that's black plastic on one side and then essentially aluminum foil on the other side, and you place it over where you believe you have an impression, and then you run an electrical charge across the sheet the aluminum foil is conducting. This causes it to pick up all of the dust that is on the floor, and then that dust is attracted to that black plastic, and now you have a dust impression on your sheet. Tricky thing about that is when you remove the electrical charge, your impression is only going to last for a couple of minutes before the dust falls off, so you do have to take tape or sticky substances to hold it all in place. So electrostatic dusting can reveal dust left with each step and create an impression. If you electrostatic dusted this classroom, it's going to have a ton of impressions. Electrostatic charges can lift impressions from paper, carpeting, wood surfaces, linoleum, asphalt, and concrete. As previously mentioned, other methods to recover latent impressions include gel lifters. These methods can provide information about the person who left that shoe print. Another big part of this part of the unit are tires. So tire treads and the impressions they leave. So your tires aren't smooth. They have a pattern on them. The reason for this is to channel water away and to provide traction with the road so you don't just slide off the road. Tire treads are divided into ridges and grooves. Tires can leave latent patent and plastic tread patterns, just like we've talked about before. Tire evidence usually indicates the type of vehicle that left that mark and may be used to link a suspect or victim to a crime scene and can reveal the events that take place. So if we find a tire track, we can figure out what car that came from. In order to record tread impressions, so the ridges and grooves of a discarded tire impression are counted across the entire width to know how many ridges and grooves there are. Unique characteristics such as wear or pebbles embedded in the grooves are noticed. A lot of people don't realize when they have things stuck in their tires, but they would leave an impression behind. And then a print of a suspect's tire is going to be taken, and we have to take one whole revolution, meaning you mark where you started and you take the impression going around the entire tire. That's because we don't know at our crime scene what part of the tire left the impression, so we need to have the whole tire. And you do this for all 4 tires. Then we can make comparisons with the impression based on what we have on the crime scene and the suspects to see if they are in fact a match. Identifying tread patterns may not be enough to link a suspect to a crime scene, but other things can help. We can do the front and rear track widths, how far apart the tires are, the wheelbase measurement, what size the tires are, and the turning diameter, how tight or wide a car takes to make a complete circle. Databases can be checked to find vehicles with these specifications. They have tread pattern databases out there, and other measurements associated with cars that you can search to narrow down what kind of car you might be looking for, or what kind of tire you're looking for. Now, one of the big things that causes us to use tires is accidents. Car accidents happen all the time, every day. So the thing with accidents is you think if a person is in a car accident, they'd be able to tell you what happened, but that's not really the case. Drivers may not recall the exact series of events before, during, and after an accident. As we've talked about before, eyewitnesses are not completely reliable, so in the event of an accident, people cannot always be relied upon to tell you what happened. People, vehicles, and objects, however, do leave evidence of their actions at a crime scene. So things like debris and tire marks can be clues to the speed, direction, and our vehicle identification. So when it comes to an accident reconstruction, we are looking for 3 basic types of tire marks. The first type is skid marks, and these can be clues to the distance when a vehicle's brakes were applied and the vehicle's speed. So essentially these are made when the driver slams on the brakes. The faster the driver was going, the farther the car is going to skid before it comes to a stop. So by measuring the length of that skid mark, we can get an approximate speed. Yaw marks show a sideways skid, and this is made when the driver has lost control of their car. Maybe they went to make a turn, they took the turn too fast, so their car starts to swerve to the side. Maybe they got in a car accident, and in order to avoid, they swerved to the side. But essentially, this usually tells us that someone lost control of their car, but can tell us things about that they were going too fast or something like that. The last type of mark is called tire scrub, and this can determine the area of impact. This is made when the car hits into something and then essentially bounces back, making a scrubbing motion. So it can tell us where a car hit into something, whether that's another car, a telephone pole, where one car hit into something else. Now we can calculate speed, and you're going to be responsible for doing this, of how a car was going. And we use the formula S, which stands for speed, equals the square root of 30 df. So you take your 30, you multiply it times the distance of the skid, that is what the D stands for, and F, which stands for drag factor. Drag factors are related to the surface that the car was driving on. You will be given a chart of common drag factors. So you multiply all those together and then square root it all to get your speed. Dental impressions are also a big part of impression evidence. So occasionally a perpetrator will leave behind a bite mark. The most famous case of this is that Ted Bundy, one of the big cases of evidence against him was that he had left a bite mark on one of his victims' buttocks, cheek, and a police officer happened to think quickly and took a picture of it, which was evidence that was used to convict him of that crime. So the differences in the size of teeth and jaws, the positions, if you've had dental fillings, crowns, caps, you have broken teeth, teeth that are crowded together, teeth that are too spaced apart, all of that makes your bite unique to you. Yes, even if you've had braces. So when we're using dental evidence, the investigation consists of recognizing, documenting, collecting, and analyzing the evidence. So if it's a bite mark and it's on like someone's skin, we're going to take pictures of it so that we can have it for comparison. But if it's in some sort of 3D object, you have a bite mark in an apple, we're going to try and take a full cast of that in order to have a physical replica of it. So depending on what the bite mark is, we might do different things with it. There are up to 76 points of comparison that can be used when comparing a suspect's dental patterns with bite marks left at the crime scene. We use bite marks and the teeth of corpses or skeletons in forensic investigations, either to identify them, as we previously talked about, or bite marks, as we are talking about now. All right, that's a lot about impressions, but that's what you need to know.